Hello everybody, we are in the Netherlands. We are at the family van Stipkip. They made a transition on their barns from 70,000 to 84,000 birds. We as Vencomatic provided a new aviary system. We also provided transport belts to transfer the eggs to the egg room, a new intermediate floor in the house, and also a full transition of the egg packing room with Brunson equipment. My colleagues, they would like to tell you something about the different things that we changed in this house and the new concept. So let's go over to them and they can tell you all about it.
Hello, I'm Victor van Wagenberg, product manager from the Vencomatic Group, and one of my products is the Eco Unit, which is a heat exchanger. And in this house for layers, we have a heat exchanger, an Eco Unit for minimum ventilation. And this is a unit that supplies the fresh air through the aviary system. So where I am standing now, you see a big tube above the aviary and also these vertical tubes. And these are here to supply the fresh air from the heat exchanger in the tubes that are integrated in the aviary system. Here and also on top there. So in this tube there is fresh preheated air that is supplied into the house and distributed by little holes you can see in the aviary system. So fresh air blown directly above the manure belt has two effects. And the first effect, that this fresh air will dry the manure. And that causes less evaporation of ammonia, but it causes evaporation of water. So the product becomes drier. And the second aspect of this, that is also the minimum ventilation. So fresh air, oxygen, is also supplied by those tubes, by the heat exchanger in the system. It's essential that this air is preheated correctly. It needs to be warm, because that gives a better dryer, but gives also then an acceptable ventilation system. If this air would be too cold, there are risks that the birds have too cold air around their feet and that gives health problems. So it needs to be preheated by a good heat exchanger to make this a success. So the minimum ventilation is supplied by the Eco Unit, is preheated air, and that gives also a very comfortable climate control. The minimum ventilation is preheated. That causes that we can increase the ventilation more. So at the minimum, we can increase the ventilation somewhat. So we have a better air quality inside, we have a healthier environment, and that gives also an effect on the production of the birds that can produce more efficiently and there is less health problems. Okay, here we are in between the two laying houses, and you see the 4 Eco Units here in one row. 2 of those Eco Units are for the house on the right side, and 2 other Eco Units are for the house on the left side. And the one out of those 2 is then for the top floor, which you can recognize that the tube goes to a high point over the roof and there connects to the air distribution system. And the other of the 2 is for the lower floor. Besides this system for minimum ventilation, for Eco Unit for minimum ventilation, Vencomatic also has a new development, which is the Eco Zero product. And Eco Zero means that all the ventilation is done by Eco Units. Then we are not using those only as a preheater for the minimum ventilation, but those units can also be used as a cooling system for the maximum ventilation. And by setting this step, going to Eco Zero, we can get a better control, even better control over the indoor climate than only with minimum ventilation, and also the emissions are reduced to the next level.
Hello, my name is Ruud van der Heijden and we are standing here next to our latest model of the Boleg Terrace. We see here the Boleg Terrace with this center belt nest. As you are known from Vencomatic, also the Boleg Terrace is equipped with the Vencomatic nest. So it has a tipping floor inside with the rubber Vencomat to maintain air quality as high as possible. And the tipping floor is driven with the gear rack system. The frame of the Boleg Terrace consists mainly out of magnelis coated steel. Magnelis has a 6 times better resistance against corrosion as normal zinc. The main frame, but also the wire mesh floors that are coming in contact with birds and manure are protected with the magnelis coating. We see here the Boleg Terrace on 2 tiers, so there is an additional level above the nest. A new feature of the Boleg Terrace is to create extra surface. We are able to make that top surface wider, but also we can do it shifted, so wider to one side left or wider to one side on the right. The Boleg Terrace comes standard with the integrated air duct, both on the bottom and the top manure belt. And as additional welfare features, we can provide the step-on rails to make the step from the floor into the system easier for the bird, but also welfare ramps to allow the birds easier to move between the different levels. The Bolecterras is well known for the bird movement within the system. So birds very easily can navigate throughout the system because it's built as a tree shape. That's one of the most unique factors of the Bolecterras system. The bottom part of the frame is always equipped with stainless steel legs. So the part that is standing constantly in the litter and manure is protected against corrosion. Under the system we have provided a litter scraper system. This system is a tool to do easy litter management, so to maintain the litter level and to reduce labor. It's also a tool against potential floor eggs. To close the area under the system off for training purposes, we have provided the Bolecterras with automatic gates. This is an harmonica type of gate. It doesn't need much strength to move it up and down, and it can be controlled from one central location. In the system we have a new feature. It's called system egg collection. So if there potentially is a mislaid egg on the slat floor, it automatically rolls by the sloped floors to the center of the system where a small egg belt is provided. And with that small egg belt, that potential system egg can be collected automatically as well. Furthermore, in the nest, the center belt nest, where the egg belt is located, above the egg belt we have provided a dust belt. This dust belt makes sure that the egg is protected and covered from any dust that can occur on the egg during the day, during the laying period. The dust belt, it's possible to remove separately from the egg belt. So with that dust belt, the egg is extra protected on the egg belt. This is the latest member of the Bolecterras family, the Bolecterras 1 tier. So the nest is positioned at the bottom and there is only one extra additional level above the nest. So different from the 2 tier Bolecterras. In this situation we see there is a white surface, a white belt over the nest. As I explained, there are different options to make the belts wider or smaller to provide surface to fit any situation. The Bolecterras is equipped with the Venco perch. This is a special perch that complies with the new welfare standards. It has the same mushroom shape as the Q perch, but it's without the electrical cable. To promote a proper bird movement throughout the system with a wide surface over the nest, we have provided the system with the welfare ramps and the step-on tubes, the rails, to create that optimal bird movement throughout the system. So the 1 tier Bolecterras is specially designed for low houses or for situations where we have to build the aviary system on 2 or 3 levels. Like this situation. In this case we have, as Vencomatic, provided together with our partner Anera the intermediate floor. So the floor structure you see here, it's a completely self-supporting and a completely independent structure from the building and from the equipment. This way we can maintain the equipment as it is designed for the birds, and we doesn't need to be in connection with the house, so we can build the floor in for any situation to suit. The floor is built up with columns. It can be coated or hot dip galvanized. The bottom part of the column is always hot dip galvanized because this one is standing in the litter. We have designed with Anera a special adjustable foot to suit any slope or any angle in the floor. The design of the floor in this situation is built to suit the ventilation system. As you see, the cross structure, the cross purlins, of the floor are situated in the direction of the air inlet, so it will support the air to flow over the equipment, over the aviary system, and bring enough fresh air in the center of the house. Anera designs all their floors according CE norm and the Eurocode for structural calculations. So we can provide for each floor the necessary calculations to meet any local requirements, local authority checks or insurance. Together with Anera, we designed a special profile that has no upstanding edges, so it will reduce dust collection and it will make cleaning of the system and the floor easier. The deck of the floor, it's built of marine plywood 18 mm with a waterproof coating, and the floor is completely airtight. Except from the holes for the egg collection and the manure collection, it will be a complete airtight surface. Another big benefit of this type of floor is that we can build it with your local installation team under supervision of Vencomatic or Anera. This is the Hercules floor conveyor. It's a flat conveyor designed to be placed directly on the concrete floor. So no channel or no pit in the house is needed anymore. That will save you a lot of issues and a lot of hassle with water in the pit, cleaning, draft and mice, rats, whatsoever. It allows a much more hygienic situation in the house. You only require a small hole in the side wall of the building to let the Hercules out, and it will save cleaning in the end. Here at the top we see the system egg belt collection system. So the eggs that occasionally can arrive on the slat floor are by this small egg belt automatically collected and brought to this small collection table, where the farmer can collect the potential system eggs centrally. Further, we see the new Pegasus egg transportation system. The Pegasus is designed to maintain full capacity while reducing the space required to bring the eggs from the system belts to the main Venco belt. The system is designed to reduce the transfers, so there is only one transfer from the system to the Pegasus and from the Pegasus to the Venco belt. And the transfer is designed in such a way that the impact on the egg is minimum. The Pegasus gives a lot of freedom to build any layout. It can transport eggs up vertically, but also down vertically, but it also can turn in any angle, which gives a lot of possibilities and flexibilities to design your egg collection system.
We're standing here next to the interface of the Maxis control. And with the Maxis control, we control all the egg belts in the house and also all the collecting belts from the house to the egg collecting room. We also measure how many eggs are being delivered by these egg belts. So based on that information, we can control the speed of the belt according to the desired capacity that we need in the egg collecting room. By controlling all these belts individually, we can make sure that there's a constant flow of eggs towards the egg collecting room. The system works on a pre-programmed schedule, so you only have to push the start button and the operator and the system will control itself based on these preferences set up by the operator. Apart from that, we also have some extra functionality. For instance, a clock function. Based on a certain time, you can make sure that the eggs are already in front of the egg packer. So when the operator walks up to the egg packer, he doesn't have to wait on the first eggs. He can start his egg collecting process right away. Additionally to the Maxis control, we've also developed the Maxis count. And the Maxis count is the sensor that we use to be able to count the number of eggs on every belt. This counter is based on camera technology, and this camera technology has a couple of advantages. And one advantage is that we can also show the images of the camera on a central screen in the egg collecting room, and therefore also creating a complete overview of the egg collection process for the operator. But this camera technology also makes sure that we have a very accurate counter, and this counter is 99.7% accurate or higher. We can do this because the camera can see whether eggs are, for instance, when the egg belt stops and it runs back a little bit, if the eggs are going forward or backward. If the eggs are going backward, they are being deducted and make sure that we don't count them double. And this way make sure that the counter is very accurate. Apart from this, both the Maxis Control and Maxis Count are what we call digital systems, and this digital system allows also for the collection of data. And with this data we can generate some very interesting and new information for the farmer. For instance, with the count we can count how many eggs there were on the belt, and with the control we know how far this belt has run. And combining these data sets makes sure that we can also provide the distribution of the number of eggs over the house. And this information can also provide new insights for the farmer and make sure that he maybe gets some new tooling to further improve the performance of his flock.
We are at the egg room right now. In the front of the egg room we have two Vencobelts 40 coming in. They will bring the eggs onto the infeed. At the beginning here, at the transition from Vencobelt to the infeed, we have the Maxis detect unit. The detect unit will detect the open leakers from the eggs. So when an open leaker is coming, it will hit the unit. There's a stop on the machine. You can take away the leaker egg, clean the area and start up again. This will be better and less contamination on your eggs on the infeed. Further on in the line, there we have the Maxis select unit. So we're going to make a selection on dirty ones, open cracks, blood spots on the eggs. So it makes a selection out of the eggs. We use this camera technique to make pictures from the eggs, to take a look on it and see if it is dirty or are there some spots on the eggs. They've been taken out in this area over here. And we have a selection on the other side over here to take the very big ones and the really small ones, the XL and the SX, out of the line. Further in the line, the eggs will arrive at this point here where we can make another selection with the overgrader unit. Just in front of the overgrader unit we have a printer. We can print every egg before it enters the grader unit. This grader will make a selection out of the stream in front of it, and it will select it in a line with MX and with LX. And we have one station on the side again where he can take out real big ones that were still in the line. So left side LX, front will be M. The M line will come onto the speed pack. Speed pack is our quickest packer unit. It can pack 40,000 eggs an hour. On this speed pack we have the buffer denester unit. We have some stacks of empty trays in spare that we can fill up in the denester. In this position the customer don't need to go every 5 minutes to the unit here, but he have more time before he need to fill up the empty trays. Eggs are put into 30 tray. 30 tray will move into the stacker unit. We're going to stack the trays 6 high. Stack is being pushed out further in the line, like we see here. Stacks on the belt and they will move into the pallet loader. Right here we are at the pallet loader. We have a 3-position pallet loader here. That means 1 position where we can stack the eggs. We have 1 position for empty dividers and 1 position for empty pallets. There's an automatically outfeed on the floor. That means when the full pallet is stacked completely, it can move out in this position right here. Then we have another pallet that can be stacked fully complete. So we have a storage of 2 full pallets. And we have the storage here from the dividers and the empty pallets. This is a 3-position pallet loader. We can extend this with another position. Then we have 2 positions to be filled and 1 empty dividers and 1 empty pallet position. So we can make a setup for every egg room. Stacks are coming into the pallet loader on the infeed side here. We have an option on the infeed belt to make a weighing system on it. In this way we can weigh 4 stacks at a time. They've been picked up by the pallet loader and pushed onto the pallet. So by weighing every 4 stacks, finally we have the total weight of the complete pallet. We can print this out on a label. You can put this label onto the pallet and you have the exact volume in kilograms on the on the pallet. Eggs coming from the grader, the L eggs. Moving on this belt, we have two options here. We go to this line or to the front to this line. We have two machines here. Both are a Princeton 70 machine. This one is adjusted on the 30 cell tray. Eggs will be packed into 30 cell tray, then they will be stacked by the ErgoStack unit, moved onto a buffer belt, and they can put the stacks into a trolley unit. Eggs moving on to this belt, they will be packed into a small package of 10 small boxes. So it's going to pick up 10 eggs at a time, fill it up in a small box. Box will be closed, and then it will move forward onto a long buffer belt where they can be collected by hand and put into boxes for transport. Hopefully we informed you enough about the options that we made at the familie van Stiphout. If you want any further information, then please contact us.